Hello, everyone, and welcome back to another episode with your girl, Audrey Codner-Gibson from ACG Math Tutoring. Hopefully, everything is going all right, and we're going to get ready to do some math. So, I'm ready. Are you set? So, let's go. Okay, everyone, as we always do, we share my screen with you. So we're going to do today changing from standard form to that slope intercept form. So we're also going to look at a little bit of graphing, but we're going to do some of that algebraic expression, going transformation from one form to the other form. So we're going to look at our Common Core standards of ACED.1 and AREI.3, AREI.10. So you know what? I always like to go with the A. So in order for us to do this, let's review what we worked on last time. So last time we did a review of those parallel and perpendicular lines, and we looked at how slope can help us identify what type of lines they are without us graphing them. So I gave you two lines. One of them is 0, 9, and 3, 7. That's representing that line 1. And for line 2, we have 3, -2, and 5, and 1. So we're going to look at our slope of line 1. And remember, the way that we identify slope is looking at its formula. So we have that y2 minus y1 over my x2 minus x1, as everyone so lovingly calls it. The numbers are really subscript, so it's really supposed to be pronounced y sub 1 minus y sub 2. Meh. Okay, or x sub 1 minus x sub 2. All right, so either way, we should get our same and correct answer. So if we look at it, the first point that we see, these are going to be my x sub 1s and my y sub 1s. So for the second point that we see, these are going to be my x sub 2s and my y sub 2s. All right, so let's plug them in. So it doesn't matter which equation or which formula we use, you're going to get the same answer. So I'm just going to use the first one just to keep it kosher. So we're going to do my y2. So my y2 is 7, my y1 is 9, my x2 is 3, and my x sub 1 is 0. So we have 7 minus 9, which gives me a -2, and 3 minus 0, that gives me 3. So since 2 over 3 doesn't get reduced because the only thing they have in common is 1, so that means my slope is a -2/3. So now I'm going to look at my slope of line 2. So again, I'm going to use the first formula, all right? So my y2 is 1 minus a -2, and we have 5 minus 3. So when you minus a negative, remember it turns positive. So 1 plus 2, that gives me 3, and then 5 minus 3, that gives me 2. So since 5 halves doesn't need to be reduced because the only thing they have in common is 1, so we're going to leave it as 3 over 2. So now we got to do a comparison. So -2/3 compared to 3 over 2. So parallel lines, they have the same slope. Are they the same answer? No. Perpendicular lines have opposite reciprocals. One's negative, one's positive. So we got opposite. 2/3 is the reciprocal of 3 halves. So we have perpendicular lines. So now we're going to look at our learning target. So you should be saying to yourself, I can transform standard form equations to slope intercept form equations. Okay, so we're going to go from that standard form, which is my ax plus by equals c, and we're going to transfer it over to y equals mx plus b. All right, so we already looked at the exit ticket, so that's already done. We're going to do some guided notes and some examples, and we're also going to get a practice before we look at the exit ticket for this lesson. So standard form to slope intercept form. So as I said, standard form is your ax plus by is equal to c, where a, b, and c are represented by numbers, and your a, which is your leading coefficient, cannot equal 0. Equal anything else except for 0. So that slope-intercept form of a linear equation is y equals mx plus b. So the m, that's going to be your slope, and the b is going to represent your intercept. And the particular intercept that we're looking for is really your y-intercept, okay? So if you have those two things, you can basically use this formula to figure out what is the equation of the line. So most of the time that slope-intercept form is basically used for graphing. So we always start with my y-intercept, aka my starting point, okay? Then you're going to use the slope to find the next point, because remember, you really just need 2 points in order to construct a line. So the helpful hint to change from standard form to slope-intercept form, you're simply just solving for y. You want to get that y by itself on one side of the equal sign, doesn't matter, but we'll try to keep it to one side, most of the time the left side. And everything else is going over to the opposite side, okay? Now, one thing I definitely want you to be aware of is when you come across a negative slope. So negative slopes can be written out in 2 ways. So let's say I have negative 1/4, okay? So when I write negative 1/4, it could be written out like this, with just the negative kind of on the outside. And sometimes you're not sure where should you put the negative. So the negative can go in the numerator, like I started off with, or it can go in the denominator. But the thing is, you cannot make both the negative or the denominator negative, okay? Only when you have a negative slope, one of them, either the numerator or the denominator, will be negative, okay? Not both, just one, okay? And you can pick which one would be correct. So let's give an example. So we have this 2x minus 3y equals 9, and this is in what's called standard form, all right? We have both variables, the x and y, on the same side of the equal sign. So in order for me to go from this standard form to the slope-intercept form, I need to solve this equation for y. So this negative 3y is going to stay right where it is. So that means everything else that's on that left-hand side needs to go to the right-hand side. And just like we've done before, in order for us to do that, we got to do the inverse operation. So my inverse operation in this case is going to be negative. So remember, the sign is always in front. If I look in front of this 2x and I don't see a negative sign, that's assuming it is a positive 2x. So the opposite of positive is negative. So that's why I'm subtracting 2x on both sides. So that's gone and that's gone. And that will give me a 0, but I don't need that placeholder of 0 because I still have this negative 3y left on the left-hand side. When I look at the right-hand side, I got 9 minus 2x. So I could write 9 minus 2x. I cannot combine that. It will not give me 7x because that 9 doesn't have an x. So they are not like terms. So if you still need more practice with the like terms, see that other video. I'll see if I can put a link up for you to kind of look directly into that video just to refresh your memory, okay? So I can write it like this, or I can write the equation like this. The reason why I can do it like this, as long as my 2 is negative and my 9 is positive, I can write it either way. So I'm going to write the word or. So now I want to solve this. So in order for me to get y by itself, I need to get rid of the negative 3. So since this is multiplication, I need to divide everything by negative 3. So negative 3 divided by 3 gives me 1. In this case, it's 1y. 9 divided by negative 3 gives me negative 3. And a negative divided by negative gives me positive. And the 2/3, and I know some people are like, oh, it's 0.75. But if you look, we're going to be graphing soon, okay? So it's going to be hard for me to figure out or to plot a point that has to go up 0.75. So just leave it as a fraction. So I will leave this as 2/3 x. Okay? So the same can go for the other one, just so I can show you both ways. So -3 divided by -3, that still gives me my 1y. Negative divided by negative gives me a positive, and I'm going to leave this as 2/3 x. Only with the slope you want to leave as a fraction, because think about it. Slope is rise over run, right? So why not leave it as a fraction? Why change it to a decimal, okay? Then we have a positive divided by a negative. That gives me a negative. And 9 divided by 3 gives me 3. All right, so we got the same exact equation. All it is just kind of rotated around. Okay, so it still means the same thing. So if I were to graph this, I want to start at the y-intercept. So my y-intercept is basically the constant. So this is my y-intercept, the -3. So my first point goes on the -3. So from that point that we just drew, I need to look at my slope, which is 2/3. So remember, slope is rise over run. And it's set up as a fraction. So all we have to do is just follow the direction. So from this point, my rise is 2, 1, 2. And my run is 3, 1, 2, 3. And then I plot my point. Okay, so I went up 2. And then I traveled over 3. And since it was positive, I went to the right 3 in order to grab my points. So now, with the best that I can, okay, that was a very lovely line. So we're going to try to graph the lines. And that's basically it. Looking at it from left to right, I'm going to have a positive slope, which we do, which is a positive 2/3. It gave me a starting point at -3, which we already plotted. And then we used the slope to plot the second point, okay? So we had to solve the equation for y. Once we did that, we used the y-intercept to plot the first point, and we used the slope to plot the second point. Let's try another one. So we have a -2x plus 5y is equal to -5. So I want to solve this equation for y. So right now, 5 is with my y. So that means that -2x needs to go to the other side. So I'm going to do the inverse, which is plus 2x. So -2x plus 2x gives me 0, but I don't need to put that placeholder because I still have my 5y. And then I have -5 plus 2x. So if you want to write 2x minus 5, so we can keep it in that slope intercept form, you can. But if you want to write 5y is equal to -5 plus 2x, that's perfectly fine too. As long as you know what's associated or next to or adjacent to your x, that's going to be your slope. The one that doesn't have an x, that will be your y-intercept. So continue on our quest to solve for y. So I'm going to divide both sides by 5. So 5 divided by 5 gives me 1 y in this case. Then I still have a positive 2/5 x, because 2 divided by 5, it won't give me a whole number, okay? Then I have a negative divided by a positive, which gives me negative, and 5 divided by 5 gives me 1. Same thing can happen over here. Dividing everything by 5. So this gives me 1y, or y. This gives me my -1 plus my 2/5 x. Okay? So the only reason why I'm doing it twice is to show you that there's more than one way of getting the same answer. Okay? So you're not wrong. All right? Cool. So we're starting at -1. That's my y-intercept. That's going to be my starting point. So from this point, I'm looking at my slope, and my slope is 2/5. So that means I'm doing a rise of 2, 1, 2, and I'm doing a run of 5, 1, 2, 3, 4, 5, and I'm plotting my point. So I'm going to try. Okay. Not too shabby, patience. Okay. So we got our equation. We got our line. We went from standard form to slope-intercept form. Hopefully you're seeing that it's so much easier to graph an equation of a line when it's in that slope-intercept form, because I can see my y-intercept and I can use my slope to get to the next point. So for practice, if you want, you can pause it. And then when I come back on, I'll just show you what exactly your answer and we'll do a comparison. So I'm first going to have to try to get y by itself. Right now, there's a negative or minus sign right in front of that y. But this negative 3x needs to go. So I'm going to add 3x to both sides. These are going to cancel out to give me 0, but I don't need to put that placeholder because I still have my negative y. And then I have my 3x plus 4, okay? Or you can say negative y is equal to 4 plus 3x. But this time, I don't have y by itself. I still have a negative there. And what's assumed to be in front of that y is a 1. And in this case, it's a negative 1. So I need to divide everything by negative 1. So a negative divided by a negative gives me a positive, and 1 divided by 1 gives me 1y, or in this case, just y, equals positive divided by negative is a negative, so a negative 3x. And the same thing, positive divided by negative will give me negative. 4 divided by 1 gives me 4. Same thing's happening here. Dividing both sides by negative 1. Then I get my y is equal to negative 4 minus 3x. So my slope is negative 3 over 1, or 3 over negative 1, okay? Then my y-intercept will be negative 4. So I'm starting at negative 4, and I'm going down 3, 1, 2, 3, and over to the right 1. Or, starting at my y-intercept, I could go up 3, 1, 2, 3, but go to the left 1, since it was a negative 1. Oh, so it doesn't matter. If I went up, I have to go to the left if it's a negative slope. If I went down, the negative's already taken care of. That means I have to go to the right for the other direction, all right? So then here, so we get roughly the idea of graphing our lines, okay? But the key part was my slope could be negative 3 over 1, or it could have been 3 over negative 1, okay? So, did we do some learning of transforming from standard form to slope-intercept form? Yes, we did. We already reviewed that exit ticket. We did some guided notes and some examples, and we did one practice. Now we just have to look at our exit ticket. So for the exit ticket, I just want you to use this one problem, okay? Go from standard form to slope-intercept form and try to graph it as best you can. So, like always, this was awesome, all right? Again, we always have a good time, but if anything, please like, subscribe, comment, and share, because we definitely don't want to keep all this knowledge amongst ourselves. So, like always, it's been a joy, and hopefully everyone's doing all right, and I'll talk with you soon. Take care.